Okay, this is going to be just a short demo lecture in which we're going to do some chemistry. So this is going to be about crude oil and what crude oil is and why it's important. So crude oil, as you can see in the barrel here, what crude oil actually is a mixture of different hydrocarbons. And a hydrocarbon is just a type of chemical that contains hydrogen and carbon. So there can be different sizes of hydrocarbons. That's called a chain length. So if it just has hydrogen and carbon in it, they're the only two atoms, then the simplest hydrocarbon that you can have is just one carbon. And so that means it will have 4 hydrogens. Because carbon makes 4 bonds and hydrogen makes 1 bond. And you measure the size of the hydrocarbon, so you measure the chain length by the number of carbons. So if it's the smallest one, the most simple one possible, is just C1H4. And then if we add another carbon, so we say now it's got 2 carbons, so it's going to be a longer chain. It's going to have 2 carbons and 6 hydrogens, so it's got C2H6, and so on. And the reason of this is because of the number of bonds carbon can make, which is 4. So each carbon, when it's just one carbon, it'll be connected to 4 hydrogens, but when there's another carbon, one of those bonds is taken up. So there's not as many hydrogens. So the formula for working out how many hydrogens there is this. So the number of hydrogens that will be in a hydrocarbon, in a chain, is 2 times number of carbons plus 2. And this will work for any chain length. So if there's one of them, if there's just one, 2 times 1 is 2, plus 2 is 4. Say this one here, so there's 3. 2 times 3, 6, plus 2 is 8. If you count them, there's 8. And so on. And that will work for any length of the chain. And the hydrocarbons, the chains can get very, very long as well. So what these are just a couple of pictures of a 3D structure. So this is one way of showing molecules and what they look like. So these are shown in 3D. So when I draw it, say I was drawing it on paper, it would have to be in 2D, and it would look like this, kind of like flat and square, but that's not the shape it is at all. In real life, it's a 3-dimensional thing, and it looks kind of like this. And how you draw that, if one of the bonds you make like a thick wedge, and the other one a little dashed line like that, that means the thick wedge, the big bond, that means it's coming towards you, and the one that's just dashed line means it's going away from you. So if you can imagine that in 3D, how it would look like. So the 2 hydrogens underneath are in the same plane. So, and then this hydrogen here is coming towards you out of the screen, and this one will be going away from you into the screen. And that's the shape that they make. So you can see here, if you look at this, the black circle, the black spheres are carbons, and the white ones are hydrogens. So if you can see this, there's these two bonds. These two bonds are in the same plane, and then this bond here is coming towards you out of the screen, and then the other one that's going into the screen away from you. So that's how the 3D structure of the hydrocarbon chain is. That's what it looks like, and this is how it's drawn. So there's lots of uses of this crude oil, and obviously the crude oil, because it's split into all these different chain lengths, the different chain lengths are all different things. So the smaller chain lengths, like this, will be made into petrol and gas, stuff like that. And the longer chain lengths, like this one, that gets made into stuff like diesel and kerosene and bitumen. So the longer the chain length is, the more thick the oil's going to be. So if it's just one carbon, that's a gas, and if it's two carbons, that's a gas as well. And so it goes on, and 3 and 4 are gas as well, and they start to become liquids, and the liquids get more and more thick the more carbons are in the chain. So depending on that, they have different uses. So we get crude oil and we separate all of the different chain lengths out, and then we have a different use for each of the sizes, each of the chain lengths. So what also can happen is polymerization. But this, before I talk about polymerization, we'll have to explain what this is. So when you have two carbons and they'd be bonded together like this. So this is C2H6, and the carbon is making 4 bonds as usual. But what can happen if I get rid of 2 bonds and then say that this carbon is doing this? So this is a double bond. The carbon just has 2 bonds to the same other carbon. And if you count them, each carbon is still only making 4 bonds, but there's less hydrogens. So there'll be 2 less hydrogens because 2 bonds to hydrogen are gone, and there's just an extra bond because of the double bond. And that's what this is. That's what this is here. So what it's called when you have a chain like this or this is an alkane, and if it has a double bond in it, it's called an alkene. So this chain could carry on, it could be any length, but it would have this double bond in it. So it would have, that means less hydrogens. So the formula, instead of 2C plus 2, it's just 2C. So the number of hydrogens is just double the number of carbons. So here, 2 carbons, 4 hydrogens, etc. And chemicals like this are very useful because they can do this thing called polymerization. And polymerization is when small molecules join together to make a large one, so a long chain. And the long chains are useful because long chains are things like plastics. This is how we make plastics. So if we've got 2 molecules here, and they've got a double bond in them, what the double bonds can do because these carbons are unsaturated, so that means they've got extra space. So that means they're not full of hydrogens because they've got less hydrogens than they should have because of this double bond. So what happens is the double bond can get broken, and then two of them can join together, and so on. And why I've drawn brackets around this, so if you imagine, you see I had the double bond here and the double bond here, and they got broken and it formed this bond here, so two of them joined together. And the same thing would have happened with another one here, and so on. So all of them join together to make a big chain. And that's called polymerization. And that can only happen when there's a double bond that can break and make them join together. So I think that's all I have time for with this. So thanks for listening.